View animations with XML are among the oldest animation techniques in Android. You define your animation in an XML file and then call it with a couple of lines of Java code. The biggest advantage of this approach is that the animation is reusable and very easy to read. But as you'll see, there are some disadvantages as well. I'm going to start by opening an existing Android Studio project for my exercise files. I'll go to my exercise files folder to Chapter 2, to the folder for this video, and I'll select the folder Animate XML and open the project. I'll open the main activity class, and then from there I'll click the related XML file icon and open the layout file. This layout file shows a single graphic, a little smiley face. The graphic is displayed in this image view component. Its source is an SVG file named IC_face that's in the resources area, and it looks like this. And then, also in the layout file, I'm coloring it with the tint attribute. I'll run the application on an emulator to see what the application looks like. In my emulator, I'm using Android 6, Marshmallow, and I'm emulating a Nexus 5X. So there's the graphic, and right now when I click the Animate button, nothing happens. Now, my goal is to make the object grow over a certain amount of time, or duration. So I'll go to my project folder, and I'll locate my resources directory. And I'm going to create a new subdirectory that I'll name ANIM for animations. Then I'll go to that folder, and I'll create a new animation resource file. Notice that Android Studio guesses that that's what I'm interested in because I right-clicked on that particular folder. I'll name the file grow.xml and click OK. An animation file starts off with a set element, and then within the set, you can add one or more animations. I'm going to add a scale animation to change the size of the object. Now, as I type in the names of each of these properties, I'll always start by typing the beginning of the word Android, and that'll pop up a list of the available properties. Not all of the available properties will appear, though. I'm going to start with one named Duration, and I'll set it to a value of 1000. That's 1000 milliseconds, or 1 second. Next, I'll set a property called FromXScale, and I'll set it to a value of 1.0. And I'll add FromYScale and set that to 1.0 as well. The scale is measured in terms of the original size of the object. So 1 means the size of the object as defined in the XML layout file. Now I'm going to double the size, and I'm going to add a 2x scale and set that to 2.0, and a 2y scale and set that to 2.0. And then I'll close that element. So that's the definition of my view animation. Now I'll go to my main activity class, and I'll add some code here in the onButtonClick method. I'll get rid of this other method that I don't need, and in this method, I'll create an instance of a class named Animation that's a member of the android.view.animation package, and I'll name it Animation. And I'll instantiate it by calling a class named AnimationUtils, and then from there I'll call the loadAnimation method. I need to pass in a context and an animation resource. The context will be this, and then my resource will be r.anim.grow, and that references the XML file that I just created. So now I have an animation object and I want to run it. Notice that I've already referenced the image view object in my XML layout file. I saved it as a private field so I could reference it elsewhere in my code. So here I'll call imageview.startAnimation, and I'll pass in the animation object. And that's all the changes I need to make in my Java code. I'll reload the app on my device, and then I'll click the Animate button. And the grow animation happens. Now notice that the view springs back to its original size after the animation is complete. That's because with this kind of animation, the object itself isn't actually being resized. Instead, the animation is only manipulating the visible pixels on the screen. Now, you can save that final state by listening for an event that tells you the animation is complete and then explicitly setting certain attributes of the object. So I'll go back to my Java code, and I'll add a little bit more code here to add a listener to the animation. I'll call animation.setAnimationListener. Then I'll pass in a new instance of an animation listener interface. This interface has 3 required methods: on animation start, animation end, and animation repeat. I'm only interested in the ending event, so I'll close up the space in the other methods, and then I'll add a bit of code here. I'll call imageView.setScaleX, and I'll pass in a value of 2, and then I'll duplicate that line of code, and I'll change the second version to setScaleY. So now I'm saying when the animation is complete, save this new state, and I'll run the app again. I'll click the Animate button, and now the scale is saved, but the object is still springing back to that centered location. Now you could add more code if you wanted to fix that as well. But it turns out that using this old-style view animation technique requires a lot of code to get it working and to stabilize it. There are better approaches that are available that remove a lot of the required code. Particularly starting with Android 3, there's a much easier way to animate the object with a class named ViewPropertyAnimator, and I'll show you how to use that technique in the next video.